features that have been introduced for the model assembly or the connector workflows. The first thing that we're going to go through today is graphics performance. One of the biggest things that we've kind of had over the last few years is with large numbers of connectors, people were seeing slow down and pan, rotate, zoom, those sorts of things. So for 24.1, we have dramatically and drastically overhauled how the connector graphic implementation works. So for a 4 million element model with 45,000 connectors, the frame rate was, with all the connectors turned on, used to be at about 6. We are now at 25 frames per second. And on a 2 million element model with 10,000 connectors, we're seeing 60 frames per second, which is pretty good with large numbers of connectors. So I know this is something that we've been got large feedback on constantly. This is something we were finally one of the last big pieces that we were addressing. Just to show you what the connectors look like now, there is a slight difference in what they actually look like today. This is because the graphics behind it changed very, very slightly. So if we zoom in a bit, we can see that they're just a slightly different type of cylinder rather than the cylinder that we had before. Connector lines also, if I zoom back out and I show everything, let's turn off the geometry. We can see that the lines as well have had some slight changes. The only entity at the moment, the connector side, that hasn't been adjusted is area connectors, and that's hopefully will make the next release. We've also enabled it so that as you change the size of the connectors, the thickness of the lines also change. So if we bump this up to something a bit silly, you can see that the line gets thicker. Drop this down again, we can see that line gets thinner, just so just to be a bit more consistent. Attachments will also now change size depending on these preferences as well. So if we put this back to a nominal value and we look at the frame rate, if we just isolate the connectors by themselves, do some rotating, we can see we're quite, from a frame rate point of view, we're quite high. Big change from a graphics point of view, but from a user point of view, everything should behave and act as it used to, just better performance. The next aspect of what we've introduced for 2024.1 is the fastener consolidation project. So this has been a long-standing, long-running process that we've introduced over all of our realizations. The fasteners were kind of the last ones to go through this process. We hope that you find this far more usable, far nicer than the current implementation. So historically, we had a flat list of realization types. You had to be kind of an expert to understand which option did what, which type did what, what this realization was slightly different from that realization. There was no tunability within the controls to change it. So if I wanted a washer, I had to change controls. If I wanted a washer with a different style, I had to change type again and type again and type again. What we've done now is consolidated to a single sort of super type, if that makes sense. Within the control, you can now specify diameters, you can specify pretension, you can configure whether it has a head or whether it has just a body, whether it generates an RB2 as a body or a C-bar. You can change how it connects to solid holes. We can change how it connects to washer layers as well. And all of these are directly within the control manager. It's a single type or a single kind of super type. And we've also got hover over icons so that you can actually understand what each of these changes does, what each of these parameters actually does for the realization point of view. So if we look at kind of a bit more of this process from a realization point of view, I can go in, define a new control. I've specified, this is an M6 type realization. So I specify that in this case, I've got holes. I want to use a hole type bolt. I set my bar diameter directly within the control. I define a parameter for my pretension. I specify that my body configuration, I can change the bolt length, so the length of the body, or I can turn the head on and off. In this case, I want the head. I can change the degrees of freedom. We can have joints are now listed in there as well. In this case, I can specify how I want it to connect to layered or whatever. I can set washer layers. So I'm pretty happy with my setup now. Select a node, obviously, same workflow as before. Generate the realization, same workflow as before. In this case, now the diameter is explicitly taken from the realization, so it generates an M6, even though the hole is significantly larger, and we've got pretension generated on the top beam of the realization. Now, if I jump back into here, this has also been extended out for, so from a type point of view, we've got cylinder, which used to be the old cylinder type realizations. And again, the same process exists here. Hover over, we show you what the diameter is, what the attribute is actually changing, how it works, what it means. Again, with this one, you can still generate pretension, you can still adjust just into the realization. So each of these options will now show you what turning the option on and off does. So you can see in this case, turning the option on shows a small change in the RB2. I turn it off, a slightly different value. But you should now be able to very easily, if a customer wants to be able to define a C-bar with 3 beams in the middle, or let's just say it's a C-beam, a joint axial, and then a C-bar, and the distribution is relatively even between them, I can specify within here my layout for that particular realization. And then we've got additional options down here. Again, these are all options that existed in realizations, but they were never necessarily cleanly exposed, and they weren't really options before. So now it's a straight shot on what the option is, how it works, and what it does. The same for the old hole options. So if we switch to, so these used to be the old bolt general types, C-bar, washer one, those sorts of ones. Same process, same workflow, everything else from that point of view is the same. We've also gone through and adjusted the connectivity area. So previously these were use hole if available, use hole if done, do this if that. These are now slight verbiage changes, so existing only, create missing, use available and remove. And then if we change to create missing, it's a bit clearer now what the actual options do. So we've refactored this slightly, just again, slight changes in verbiage, commonize the language across the different options, how they work. So it should be now a bit nicer to be able to get the realization that you're looking for, hopefully within this setup. And then some of the others we've also renamed just to bring them in line. And then if we jump to help, we go to connectors, under realizations, under fastener. You can see in the help documentation, it's also now meets that. So it's a far cleaner implementation from a help point of view. And then again, all of the options are documented, an explanation of what they do, how they work, clean up on language, that sort of things. So it's a big step forward in terms of customizability. Theoretically, hopefully, there should be no need for any customers to have a custom FE configuration file for fasteners anymore. You should be able to define everything directly within the product. And then the last bit from my side before Stephanus takes over is we've added the ability for users to define features themselves. Now, we've had the feature manager, and I'll go into more of this on in the topology session. But we've had the ability for users to define features historically. Connectors will now listen to user-defined features. So in this particular use case, I've got an open hole that we would never be able to realize to normally. I can select the lines, define it as an open hole, create the feature directly, and then I can create a connector. Same process as I would normally. In this case, I don't have a control predefined, so I'm defining my control on the fly. Can specify wash delay stuff and realize. You can see it uses the definition that's come out of those lines as the whole. We've also, it also allows you at the moment for FE geometry for you to be able to defeature that feature if you wanted to as well. That also works. Very quickly, if I jump to, where's that model? Here it is. I jump to this particular model, for example. I'm just going to delete these because I forgot to delete them before. Okay. So for these two holes here, it's very difficult for the hole detection to be able to actually be able to pick these up due to the way it, basically due to the nature of the fact that it rolls out onto almost a flat plate through here. So what we can do is we can define as 3D holes. In this case, I can select the surfaces directly. They're not an open hole like that. Create. Creates a feature for that particular surface, and I can do another one over here. Because I know those are not going to be able to be picked up from a connector point of view. And then I can go through and generate 1 and 2. Find the control that I've got and realize. And you can see here, it's picked up that surface definition and realized to all the nodes in that surface definition. So historically, this was never available, but it does allow for a bit more flexibility from the connector point of view in areas where you wouldn't ordinarily be able to get your connectors to realize. Same thing for something like this, where in this particular case, each of these sort of edges of the lines in this open hinge that again isn't a hole, isn't really a tube. We're able to define features on these lines through here. And then I can get a connector in this case to realize and join the whole thing together. Again, something that wasn't historically available, but is available now. And on that, I'll hand over to Stefanos.
So hello everyone, my name is Stefanos. I'm working with a team as an application specialist. Today I'm going to present to you a new feature we're introducing in 2024.1 for connectors. So we're introducing a couple of new connector preferences. These preferences control how connectors should automatically react on link changes. These changes could be a property, the position of the link, or the organization, let's say, of a component. Now, you can see here these two new preferences that we're introducing. So connectors might have a physical dependence on a signal, or a calculation might be dependent, an internal calculation might be dependent on some link properties, let's say. So by changing set properties, the connector might become invalid. And with these options that we're introducing, the user can automatically be notified that some connectors are invalid and should be reapplied, or their realization might happen automatically. So for physical changes, for example, we're introducing four options: nothing, modified, unrealized, and realize. Modified will automatically put all connectors that are affected by a change on a modified state. Unrealized will do the same, but it will unrealize the connectors. And realize will unrealize all the connectors and re-realize them automatically. So the user will not see anything change, but everything will be done automatically due to the change on the signal. For calculation changes, we also support these options, but we have also added the ability to update the connectors. The update operation redoes the internal calculations without unrealizing though. And in that case, it ensures that IDs are preserved. So this is the difference between physical and calculation changes. Now, something we should keep in mind is that in some cases, a connector might have both a physical dependence on a property, but also some calculations might be dependent on the same property. For example, sim quads can be dependent physically on the thickness of the links, but also the properties of the sim quads can be calculated from the same thicknesses. In such cases, we have decided that the physical preferences should win, let's say, over the calculation ones. These options also work when moving links around. So when we move link, and for example, if we have set the physical changes to realize, because the movement of the link affects the physical realization, this will unrealize the connector automatically and re-realize it accordingly. Now, if a link moves outside of the given tolerance, then the connector will automatically fail. I should note also that these options control changes that are made on the links, not on the connectors themselves. So if we modify a connector directly, then the connector will be put on a modified state, which is the case also on previous releases. So this is only for link changes, not if we modify the connector control itself. I have some videos that I'm going to show you. Before that, though, the defaults we have set to nothing. So when you open up 2024.1, if you don't change these preferences, it will work as with previous versions. So the user will have to change this from nothing to whatever he desires in order for these new options to have an effect. So let's start with the physical changes. I have a video here showcasing all the options so you can understand it. I have two SIM quad connectors. And when I go to preferences, as you can see, I can change from nothing to modified on the physical changes. These connectors are thickness dependent, so the realization depends on the thickness of the parts. So very easily, I can go and change, let's say, the thickness of the parts from the properties. And as you can see, the connectors automatically are put in a modified state. Now for unrealize, we will do the same thing. Again, we will change the property and the connectors automatically unrealize. Lastly, I wanted also to showcase what happens when we move links around. And I'm going to do that with the realize option. A question I got was that if we need to lock in the movement of the link, or if it will also work when moving around interactively. So the answer to that is that we have to lock in the movement. So we have to enter the movement or click on the graphics area in order for the whole operation to be done. It will not be done interactively while moving around. Now for calculation changes as well, I have a small video here. Here I'm using HyLock and Spring Rigid connectors. HyLock use the Rootman method, which is for internal calculations, while Spring Rigid uses the Huth method. Again, these are dependent on the thickness of the parts. So as you can see, by changing the thickness, the internal calculations are no longer valid, and so the connectors automatically react to that to notify the user. On this video, it's not really clear how update differs from realize, because the user can't see the IDs and if the IDs change or not. But I have another video to showcase exactly this difference between realize and update. So as I said, this is the video that showcases this difference. Again, we have some Spring Rigid connectors. Some of them are realized, one of them is not. So we will set calculation changes to realize and realize the connector. Now, by using Control Q, we can inspect the IDs of the elements that are generated. If we change the thickness and inspect again the IDs, you can see that the IDs have changed. Now, Now, if we go back and set the calculation changes to update, and realize the connector again to be on the plain fieldless for the purposes of the example. We inspect again the IDs of the elements. We change the property, and as you can see, the IDs remain the same. So that was all from me as well. I can showcase this on a live demo as well, although I think the videos are more than enough to explain this new feature. Again, we have two SIM quad connectors in this case. These are the preferences adder connectors for physical and calculation changes. And I can showcase what I meant by the movement. If we move interactively, let's say this plate, the connector doesn't react to the interactive movement. We have to secure the movement in place. And as you can see, in this case, the connector did fail due to the movement, due to the link moving outside of the tolerance. Same thing with the properties. We can change the property, and as you can see, the connectors automatically update their realization accordingly so that they are still valid. That was also all from my side.